Hello everyone. What I realized after I posted the information in regard to endo and exocytosis and the cell cycle is that those times that I had the whiteboard in front of me, you really couldn't hear the information that clearly. So I'm going to go back to the segment where I was talking about the cell cycle to make sure that you understand the information. So I'm just going to go through each one of the stages and advise you what's going on in each stage. So starting with interphase. Interphase was this portion of the diagram. And interphase, there are a few things that go on. Oh, excuse me, I knocked it by accident. A few things that go on during interphase. Number one, the nucleus is still very visible. The chromosomes, you cannot see individual chromosomes. It's still nuclear bound. And during this stage is when the cell is actually preparing to undergo mitosis. It used to be thought that during interphase nothing was going on, but what we have found is that the cell spends most of its time in interphase preparing to undergo that mitotic division. Okay, so then we move to the next segment, which is prophase. Prophase, identifying the diagram numbers as 1 and 2. As I was indicating in the earlier segment, I'm not concerned that you know what goes on in early prophase and late prophase. They detail that in the textbook, but I'm looking for what's all-encompassing. So what's all-encompassing in prophase includes the following. Number one, the appearance of the spindle fibers. The spindle fibers are these long fibers that attach to the chromosomes. Additionally, you can see the development of the centrioles. Centrioles will eventually migrate to the opposite poles of the cell, and in conjunction with the spindle fibers will assist in pulling the chromosomes apart. We actually have, as humans, 23 pair of chromosomes, and I think I indicated that when I was talking about it in the previous segment. Also, you will also notice that during prophase, initially the nuclear envelope or membrane is still intact, but by the end of this stage, it disappears. The chromosomes appear very long and thin, but by the end of the stage, you will notice that the chromosomes themselves actually begin to pair up. This pairing up occurs, the spindle fibers elongate, the centrioles begin to migrate to the poles of the cells, but they have not completed that migration. That does not occur until we get to metaphase. Metaphase starts with M. The chromosomes line up in the middle of the cell, as I indicated in the previous video lecture. In addition to that, you will notice that the centrioles do migrate to the opposite poles of the cell. The spindle fibers are attached to the chromosomes. That's in reference to both pictures 3 and 4. So pictures 3 and 4 are referencing the stage metaphase. Starts with M, chromosomes line up in the middle, and the centrioles migrate to the opposite poles of the cell. Finally, not finally, but once metaphase has completed, we move on to the next stage, which is anaphase. Anaphase starts with A. The chromosomes are pulled apart. And also what you will notice in anaphase, notice the shape of the cell goes from more of a rounded structure to more of an ovoid or oval type of structure, because as the spindle fibers contract and the centrioles begin to pull them to the opposite poles of the cell, then each segment goes over to the opposite pole. Therefore, the cell itself begins to elongate, because that will move us into the next stage of mitosis, which is telophase. Telophase starts with T. There, at the end of telophase, there's the development of 2 daughter cells. They are called daughter cells because they are identical in every way to the original parent cell. There are a few other things that occur in telophase, but I want to show you pictures 6 and 7, on the diagram, which are both representative of what goes on during telophase. As I indicated, during telophase, at the end of it, there's the development of the two daughter cells. However, some of the other things that occur in telophase before the completion of those daughter cells, the complete division of those daughter cells, are as follows. Here, in diagram number 6, you will notice that there is what looks like a pinching in of the cells. This is actually division of the cytoplasm. And when the cytoplasm divides, the nucleus also has to divide. So, division of the cytoplasm actually has a scientific name, as well as division of the nucleus having a scientific name. Division of the cytoplasm is called cytokinesis. Cytokinesis occurs once this cleavage furrow, or the pinching in, like I was indicating, actually completes itself. Cytoplasmic division is called cytokinesis. Division of the nucleus is called karyokinesis. Now, what we can't see in the diagram in number 6 is the reformation of the nuclear envelope or the nuclear membrane. But the chromosomes will begin to look long and thin again. They are no longer paired because the identical number of chromosomes that were in the parent cell also have to be in each one of the daughter cells. So after the cleavage furrow begins, cytokinesis occurs, karyokinesis occurs, and by the end of telophase, we have diagram number 7, which indicates 2 distinct daughter cells. Now, in diagram number 7, you will notice that the nuclear membrane or envelope does reappear. In addition to that, the chromosomes are really becoming longer and thinner so that we cannot discern each individual chromosome. And you'll notice that the centrioles, well, number 1, the asterase and the spindle fibers have completely disappeared, and the centrioles are now beginning to shift toward one area of the cell, and they will eventually no longer be visible as well. So I just wanted to highlight that information because I believe you probably may not have been able to hear it very clearly when I had the whiteboard in front of me. If you have any questions about any of the information, please feel free to contact me. Have a wonderful day.